It's time, should we? Okay, hi, good afternoon, welcome everyone. This is the Detnet working group meeting. Louis and myself are the chairs, and Ethan is our secretary. He is remote, couldn't make it to this meeting. You find the online the agenda online at the usual place, and the working group information. This is the IETF note well as a reminder, and I would like to remind you that by participating in the IETF, you agree to follow the IETF processes and policies. If you are aware that any IETF contribution is covered by patents or patent applications that are owned or controlled by you or your sponsor, you must disclose that fact or not participate in the discussion. And also remind you that there is permanent recording, and by participating and attending, you acknowledge that written audio and video and photographic records are made at these meetings. If you are not familiar with the note, well, then please study. I mentioned the recording and the minute taking. We use Etherpad. Please join Etherpad. This is join minute taking, and correct if something was not captured. For example, your name, as we discussed, you may have difficulty to capture that. Jabber and online agenda was mentioned already. The blue sheets are going on. Please fill in the blue sheets with your name and affiliation. We have two sessions this afternoon, two Detnet sessions. This one and the beverage break, and the afternoon session 2. Both sessions are in this meeting room. And this is the detailed agenda, kind of the agenda items in the order of the ones being progressed most farthest are the first. I would not read out the agenda, you can find it online. This is for the session 2. So this is the plan to go through these items in this order. And important to highlight that we use the mailing list to build the consensus. So the working group decisions are made on the mailing list. Discussion is made on the list. So please bring your items to the list, discuss and comment the documents. You will hear a couple of call for comments if you wish in the ones we are about to finalize, or bring in new topics and so on. IPR, I mentioned that IPRs has to be disclosed, and we are making call for patents prior moving to next steps with working group documents before adoption and working group last call. Or each author has to respond to this calls. This is a status update on where we are with our documents in the working group. We have 2 new RFCs out, the problem statement and the use cases. Thank you very much for all who contributed. So these are the first RFCs of the working group. And the architecture is with the RFC editor. We are making fine polishing. A couple of last edits are in the queue, and hopefully it gets published very soon. The first block you see here as on the agenda is the data plane documents. The dark green ones are the ones more stable. We plan to go for working group last call after the meeting, but we will discuss more in detail during the agenda, during the data plane presentation. And the green ones are followed by the flow information model that is progressing, as well as the Yang documents building on the flow information model. There is a new one, the Lilac one, recently adopted by the working group on the bounded latency. And one of the working group drafts is not on agenda, it is a security draft. This has been gated by previous documents, actually the architecture and the data plane solution documents. Now those are getting major, so I would expect making next steps with the security draft as well. So in comparison to our milestones of our deliverables as a working group, the architecture is done pretty much, I would say, and security, as I mentioned, will be catching up hopefully very soon. And we made a great progress in documenting the data plane definition. So actually, there is no technical changes, but the documentation was the one that was progressing. So you will see more in detail. I'll not talk about that. And I mentioned the flow information and the Yang models. That was it.
Yeah. Keep in mind we're contribution driven, and we do take items into the working group that are within Charter. And if you have something that's outside of Charter, we can discuss that. We do have something on the agenda today, which is borderline of that. The control plane information document. The control plane it is within our charter to document control plane requirements and perhaps even a framework for a solution, but the solutions themselves are outside our charter. Our current expectation is that that will be addressed in the groups that own those respective control plane protocols. If for some reason those groups, it doesn't make sense to do it in those groups, we can talk about doing it here, but that is something that would be a broadening of the charter and require our AD and ISG approval. But other items that are within charter, please feel free to come with your contributions. So first up, Don, in place of Raj, yes.
So my name is Tom Guy. I'm going to just walk you through the restructuring that we did in the data plane drafts and the list of editors that is on there.
I think the microphone is off. Thank you, Andy, for letting us know.
Hello?
Yeah, it's a little better.
Okay. Again, my name's Don Fedek, and I'm going to talk about the data plane drafts. Balaz, he's on vacation somewhere, so but he put these slides together. But the group of editors, we worked on the drafts together, and we worked on the restructuring. So prior to this, we had two data plane drafts. We had an IP solutions draft and a MPLS solutions. And what the working group had agreed to do was take a building block approach and break the documents up into the ones you see on the right-hand side. So there's a framework document, and I'm going to talk about each one of these: an IP document, an MPLS document, and a Detnet IP over MPLS document, and an MPLS over UDP document. We haven't made as much progress on the TSN documents yet. We'll just include a little bit about them. So they're basically broken up into the framework and the IP and MPLS, and then some of the combinations that you can do with them. So the framework document is basically the overall aspect of Detnet, looking at the pieces that are common across the technologies. It covers basically the general concepts, and then each one of the data plane drafts goes into more detail with respect to that data plane. So it covers, we have on the right-hand side, we have from the architecture, the layering that we've got. So we've got the service sublayer and the forwarding sublayer, and then the lower layers, et cetera. And then we've got, as services for deterministic networking, we've got IP and MPLS, and we talk about pieces like the encapsulation, specific metadata, the IP data plane, the MPLS name plane, and then things like service protection, aggregation, end systems, and subnetwork, and a little bit about controller plane management and control considerations. And at the bottom side, we have a little bit of a representation of some service examples where, like we said, the building block approach is you may get it all over one technology, or you may use combinations of the technology. So for the IP draft, this content now is specific to IP, and with the IP data plane, basically you only have the forwarding sublayer. We're looking at naturally at the elements in the IP header, the six tuple, 5 tuple, and plus div code points for flow identification and types of aggregation and things like that. And on the right-hand side from the draft, we have an example of a Detnet service that's end-to-end, or below that we have one where the actual IP service is not Detnet aware, but it travels over top of a Detnet IP network. So the management and control information summary for that, you've got the various fields that you can look at in the IP header. So for V4 and V6, you've got source address, source prefix if you're doing aggregation, destination address field, destination prefix, the protocol, the next header field in IPv6. You got the type of service or the traffic class fields, and you may do some bit masking on those. There were some comments. I see David going to the mic. There were some comments about the IP draft, and we're going to resolve those. So there was a discussion on there. You want to elaborate?
Do you want to finish the slides, or should I ask the question since I'm trying to write the new text for you right now as you're speaking?
I think you're saying you want to wait to the end.
No, I think he said he wants to have a discussion now, so while you're talking, he can write the text that's going to
go ahead.
Go ahead.
Your choice. It's probably actually. Why don't you finish the slides?
Real-time fixing is appreciated. So if anything that helps you write the right text, we should do. So what's your preference?
Okay. Let's do the right thing by the working group. Finish the slides. Come back to this one, and I'll ask a question on it.
Okay. All right.
David, remember slide 5.
So the rest of the fields, the TCP and UDP source port and destination port, and then if it's IPsec, the header SPI field. For MPLS, we did the similar thing to IP, but now in the MPLS context. So everything in the MPLS document is Detnet with respect to MPLS. So at the top, we have the representation of the service layer and the forwarding layer and an MPLS that consists of a control word and a service label, or sometimes it could be an aggregation label. And for the forwarding piece, it's the F label. For the we outline the various MPLS data plane procedures for flow identification and sequence numbers, and then management and control information. And again, in the diagrams that come out of the document, you've got a little bit more detail in the header stack that goes on there with the control word and the service label, and optionally the forwarding labels if you have them or not. So in terms of MPLS, there's a rich set of features that are in there, and we can talk about them in basically the different places they occur. So in the service sublayer information, you've got application flow identification information. You might have sequence number. You might have the S label for the service. You might have packet replication functions, PRF, whether it's used or not, and associating forwarding and sublayer information. For receiving traffic on the service sublayer, you've got the associated forwarding sublayer information, the service label for the received service, packet elimination or ordering functions, if they're provided, and sequence number. In service aggregation, the S labels or F labels that are to be carried over each aggregated service if you have aggregation. the A label associated with each aggregated service or other service label information summarized above. In the forwarding sublayer, you've got the outgoing F label stack and traffic parameters associated with a specific label on the stack. You've got the outgoing interface and the next hop for unicast traffic and any subnetwork specific parameters. On the receiving side, you've got the incoming interface, the incoming forwarding label stack to be popped, and incoming flows sublayer. And the note at the bottom just says the required information depends on the type of node. So this is the set of capabilities. You may use a subset of that. So now the MPLS and IP were the two main things, and now we're looking at some of the building blocks capabilities where you've got one type of service over another. So for IP over MPLS, there's a data plane document, and it specifies considerations for carrying IP over MPLS. It looks at the flow identification and the traffic treatment, and any and then we'll get to the management and control information summary. On the right-hand side, you've got the diagram here showing the IP service that's going over top of the MPLS Detnet, and that could be a IP Detnet service going over the MPLS system. And then we've got the representation of the various label stacks and sublayer information that you could have. For the application flow, you've got the application flow, and then if you're going across MPLS, and then the link subnet layers that you can go across, L2, times sensitive networking, or UDP, depending upon the system. So just the summary of the IP over MPLS information here at the ingress node. Each MPLS flow is identified using the IP flow information, and it includes the wildcards, port ranges, and the ability to ignore specific IP fields, as we saw before. The Detnet MPLS service that is being used to send the matching IP traffic includes both service and traffic delivery information. At the MPLS egress node, I think there's a typo in here. The S label basically that's associated with the MPLS, basically the IP is encapsulated traffic, is what we're looking at. That's straight out of the document, and we need to fix that in the document. For each S label, how the received traffic is to be handled. The next document we're looking at is MPLS over UDP IP. So the reverse of the last case in a little bit. In this case, we've got specific MPLS deterministic networking data plane operation over an IP network. So in cases where you don't have MPLS end-to-end, you can operate it over IP. And we've got the management and control information for that. So for that one, we've got the label information, the service label or the forwarding label to be mapped to the IP UDP flow, the IPv4 and IPv6 source address information, the destination address information, the service and the IPv6 traffic class fields on the UDP source port or UDP destination port. As I mentioned before, these documents are, the TSN related cases are not complete yet, but there are 3 drafts that are intended to be worked on for the next session, the next meeting. So that's Detnet IP over TSN, and then we've got Detnet MPLS over TSN, and then we've got TSN or Ethernet VPN over MPLS. We created the drafts during the split because there was material in them, but there's further work needed, and any contributions are welcome. So what we're looking for is to get a last call on these 5 documents: the framework, the IP document, the MPLS document, and the IP over MPLS document, and the MPLS and MPLS over UDP documents. And at this point, I think we'll go back to slide 5.
One comment here. We are in an unusual situation, and one we generally like to avoid, where we have chairs contributing to the drafts. To manage that, we have identified and we've appreciated that Ethan, our secretary, is going to be shepherd for these documents. So we want to recognize that we are in this unusual situation, and also tell you how we're handling it.
Yes, thank you. Yes. Thank you, Ethan. Welcome to your trial by fire. Let's go back to slide 4, actually, because I sent a note to the list.
Name, please.
Sorry, David Black. So I sent a note to the list with 3 transport returns in the IP draft. First one was responded to with, "Yep, forgot to fix that one. We'll fix." So let's go deal with the other 2. Starting with this slide, flow identification 6-tuple. Short summary is that while you identify the flow with the 6-tuple, the 5-tuple subset of the 6-tuple has to be unique with respect to all other 5-tuple flows on the network. And I'm busy writing text for that.
Okay.
So I think there's a subtlety there that the rest of us are not following.
Okay, so the subtlety.
So I think the short answer is, yeah, that seems obvious. So
okay.
I don't think you would be coming to the mic to say something obvious.
I'll quickly explain. So apologies, those of us who spend time in transport count to 5 in our sleep. So a 5-tuple is IP source and destination addresses, the protocol you're using at layer 4, and 2 ports that protocol. That's the 5-tuple. The 6-tuple adds a DSCP. What's going on here is the diff-serve architecture says you use DSCPs to mark flows. You don't use DSCPs to subdivide a flow into subflows. And so what that implies for the IP draft is it's fine to use a 6-tuple to identify the flow. In fact, I can think of some good implementation reasons to want the DSCP to be spec'd as part of your flow identification. But the 5-tuple's got to be unique because you're building on diff-serve, and diff-serve says the flow is 5-tuple.
I think it'll be important to, in this text that you're proposing, to capture what the implication is that you see that of that uniqueness.
Okay, there are 2 implications. One which is easy, and I'll do the hard one later. The easy implication is there are a few places in diff-serve where you can mark a flow with more than one DSCP. The decision to identify the flow by a 6-tuple says Detnet can't do that. No big deal. That's a design decision Detnet's more than entitled to make.
We're going to change the flow identification to, rather than be a mask, to be a list. And if it's a list, it allows for that.
Not when there's text in the IP draft that says a 6-tuple uniquely identifies the flow full stop.
It's the 6-tuple, including masks and other things that are shown on the.
Okay, in which case we have some interesting text to write. I was writing text against 6-tuple being unique. The other point is that because a Detnet flow is also a flow that IP and diff-serve expect to be a flow, you've got to be able to, outside a Detnet context, use that 5-tuple as a handle on the flow. And therefore, it can't be the case that this 5-tuple, source, destination, protocol, 2 ports, with an EF-DSCP is one flow, and with a CS1 DSCP is a different flow. If you've chosen to mark it with EF, you want another flow, change one of the ports or something like that.
What does a different flow mean to you? Are you talking about from an application standpoint or from a network standpoint?
Network standpoint, in particular, diff-serve architecture.
What's the implication of that, David? What's the implication of what does it mean to be a different flow? I mean, if you're saying different flow from an application perspective means, I have a voice, voice on a voice versus video, and we're combining them, and the only difference is DSCP. That's clearly forbidden. I get that. From a network standpoint, if it's going to receive a different traffic treatment, it's a different flow. I mean, and so that's what DiffServ does, is give different traffic treatment.
Right, DiffServ gives different traffic treatments. We try not to subdivide 5 tuples.
So I'm not sure. It'd be very important to capture if there's what restrictions there are on the network equipment based on that statement. I think we're okay with the statement, particularly from the context of how it impacts applications, because certainly that's a no-brainer, right? I mean, no one's going to argue about that one. No one's going to misinterpret that one. But in terms of actual network equipment, what behavior they have to do differently, that's what we have to make sure we cover.
I think the best thing to do at this point is probably let's take it offline, because it sounds like I'm working from text. It's about to get changed. Let's take it offline, figure out what the new text is, and then work and then work the issue from there.
Before you go, could you explain
microphone, please, and name?
Stuart Bryant. I'm still curious as to how the 5 tuple doesn't uniquely define a flow. Assuming we exclude NATs, I don't understand. They are a unique description of a flow.
You and I are in bound agreement.
And I think I am too. I'm just confused.
You and I are in bound agreement. The problem is there's some text in the draft that isn't as precise in this point as it ought to be, and the best bet here is let's see what happens when the edit that Lou describes gets made, and I'll try to figure it out from there.
Yeah, it would be good. Let's see the text and work on from it. Yes.
Yeah.
I have a second part, but let's finish this one.
Norm Finn. I assume it's okay in a flow if I've got a flow with different if I've got a 5 tuple and I've got different DSCPs, that the packets get out of order. Because
that depends on the DSCP. It's true unless otherwise specified, and there's a very important otherwise specified called AF.
Well, because I think our intention here is that when identifying the flow, we're talking about, in some of the drafts, we're talking about identifying the flow because different flows may have to go into different queues, for example, in order to get the quality of service we want. And that when deciding which queue a flow goes into, the DSCP is very important. Deciding which queue a packet goes into, the DSCP is an important distinction.
Correct, and hence, when the DSCP is picking off the queue, and you don't want reordering within a flow, don't use DSCPs in that flow that pick off different queues and cause reordering. Is the punchline. Okay, I think we're agreeing, but I need to see the rewritten text and take it off.
Actually, if that's the text you want to put in as the implication, I think everyone will violently agree with that.
I just need to see it. Okay, I think we're good. Did you have one more, Stuart, or should I go on the question?
My head around when you want to use different DSCPs to the same
microphone, please. If you're going to have a conversation, it's got to go.
I'm just trying to get my head around. I know I've been working on this. I'm trying to get my head around when you actually want different DSCPs in the to essentially the same UDP port because it's going to the same service on the same application.
Generally, we don't worry about the applications here. That's for someone else to worry about above us. So we're providing tools that
nonetheless, I think we should probably put some clarification there because I'm trying to figure out why you do it.
Let's see. I think the best thing I can probably do here, try to make it a short discussion, is probably to point you over towards WebRTC, which is trying to do an awful lot of multiplexing of an awful lot of stuff. But in general, this is a Dr. Hertz when I do that, don't do that discussion. We simply need to find the precise words to say don't do that.
Okay, so Stuart again. So if we are going to have this distinction, it would be really handy if someone were to provide an example, because having thought about it now, I'm confused. I'm sure some of our readers will be confused.
It is part of the current internet architecture that's supported. So we're not going to revisit the internet architecture in this working group.
No.
So the internet architecture allows this case.
Okay.
We don't see any reason to disallow this case. Sorry, the working group has never suggested disallowing this case before. If we think we should be disallowing part of what is supported in the internet architecture, number one, we got to be really sure that we were doing that. We're going to change the internet architecture. And number two is we'll have to reach consensus on that.
Right. So well, let's go back. I mean, it would be useful, at least for many people, I think, if we just crystallized an example of a case where you'd want to do this, or we call out that actually no one seems to do it.
I think you should go read about diffserv, because diffserv talks a lot about this.
So, Stuart, the simple case you might be looking at is diffserv defines a piece of functionality that Detnet probably isn't interested in. It's called AF. It's called assured forwarding. Inside an AF class, say AF3, has 3 DSCPs in increasing order, in order of drop precedence. Detnet can't drop traffic. Therefore, if Detnet wants to use AF3, AF31 suffices. Don't touch the other two. It doesn't make any difference. Aha. I see Stuart's head nodding vertically, so at least an example has been communicated.
Yeah, I think we need to get something around that in the text, because I am sure that the other readers will find it useful. But since you're writing some text.
Yeah, I signed up for that one when I hit send on the email. Okay, now we've done that. Let me go through one I'm confused about. So what is the purpose of the management and control information? What I'm trying to figure out here is what to do with the V4 type of, what to do about the V4 type of service and V6 traffic class fields. So what I'd like to understand, what is the information on this slide used for?
Well, this slide is basically saying these are the fields that you can choose to identify the traffic. It doesn't have to be all of them at once.
Okay, if this is, okay, I'm almost inclined to split a hair and ask what the heck is it, what do you mean by identify? That's probably not a productive question to ask.
Traffic classification.
Okay, for traffic classification, the type of service and V6 traffic class fields then need to be split, because the ECN field is in there. Thou shalt not use the ECN field to identify traffic. That's the easy one. And then the DSCP is the other 6 bits in those 2 fields. You can use the DSCP, and you are using DSCP to identify and classify traffic. That's fine.
Yeah, I think that's some clarifying text. We've already identified that we have to fix that. I believe it's broken out in the document. The field is broken out.
This was copied out of the document. It's going to have to be rewritten to split the type of service and traffic class fields into DSCP and ECN fields, and the bit mask hits the bit bucket. And it sounds like what I need to do is I need to go take what I just said and write a longer email message about what has to change, what needs to change here, and why. Now I understand that the purpose of this is traffic classification, which to me means these are the fields that you can use in a filter to carve out the very small chunk of traffic that has to go through the Detnet forwarding plane in the node.
Yeah.
Please propose text.
Will do.
Thank you. Any other comments? I think I'm done then.
Okay, so this is an update on the flow information draft. So what happened to this draft since the previous IETF The last IETF presentation was given on what changes we see to be made, we see as authors, contributors, and actually we implemented those changes. So this new version 4 is an implementation of the IETF 104 presentation as a contribution to the group from the authors. And I keep saying and highlighting that please review and comment and chime in. So this is just a contribution from the authors to capture the changes needed. So it implies actually a major rewrite or reorganization compared to the previous version of the draft. The figure you see on the screen is taken from the MPLS data plane draft, and 3 components are highlighted. There are the applications and 1 directional flows on the screen. There is the blue one on top, which is the application flow, and there is a gray one, the Detnet flow, which goes through the Detnet service layer. So these are the terms I will be referring back to in a minute. Before that, what is the scope of this document? The 2 top bullets, the black ones, are the scope. So to provide and describe Detnet flow information model, describe the characteristics of Detnet flows, requirements, attributes that are needed to handle the Detnet flows in the Detnet network. As well, to provide a service information model, like describing what service Detnet service a Detnet network provides towards the Detnet flows. And the third one is out of scope for this document, but that's definitely part of the full picture. That's why it is here. That's the configuration data model, and that's scope of the Yang documents you will hear about after me in this session. Just a terminology summary. What you see on the left-hand side is coming from the architecture, and on the right-hand side we propose to use some new terms in the document to be able to refer to these items to make easier the description. So an application flow, let's talk about the left-hand side, the architecture. An application flow from Detnet perspective is the data, the payload carried over a Detnet service or in a Detnet flow. And a Detnet flow is actually an application flow plus the Detnet encapsulations, including MPLS, if it is MPLS, or IP, or sequence numbers, and so on and so forth. So all what is specified by Detnet as needed to provide the Detnet services. I would like to highlight these 2 notes in the bottom that in some of the cases, the app flow and the Detnet flow may look like the very same on the wire. You find this in the IP data plane draft as well, that the IP application flow headers remain and just used in by the Detnet nodes within the Detnet domain. There may be no further encapsulation added. The second note points on one way the aggregation can be done. And if we do an aggregation, actually aggregating multiple Detnet flows into a single Detnet flow, it can be viewed as Detnet flows being aggregated becoming app flows from the perspective of the aggregate Detnet flow. You will see more details on this in the following slides. New terms that we propose for the description, source being the reference point for the application flow, the originator application of the Detnet of the application flow. Destination is still refers to an app flow. That's the termination point of the app flow. And the two bottom ones, Detnet ingress and Detnet egress, refer to the Detnet flow. So these are reference points. The ingress one is the starting point from the Detnet network perspective for the Detnet flow, and the Detnet egress is the termination point for the Detnet domain, Detnet network for that Detnet flow. So these terms are used in the following, and there are three aspects, three groups captured in this document as information elements or groups models. The bottom two are the two that are really the scope of the document, the Detnet flow parameters and the Detnet service parameters. On top you see the app flow, which is not the core, but we need to talk about it. We need to have an understanding in order to be able to provide the Detnet service for an app flow. So the Detnet flow related parameters describe the Detnet flow characteristics, requirements, and so on. And the Detnet service related parameters provide a description on what the service provides towards the flows. Bit more in detail. Actually, this is a single slide summary of the whole document currently. So as I mentioned, the core part is the green and the blue in the box titled with the title or the name of the draft IETF Detnet flow information model. So that's the core part. And in dashed line in the red box, there is a app flow. As I said, we need to have an understanding, and in some cases, actually, Detnet flows become app flows. Let's do it top down or from left to right in this case. So an app flow has two kinds of groups. It has some characteristics describing the flow, and it has some requirements. As part of the characteristics, we propose to have a flow ID, which is only a management ID. I will call out an example when it is handy. We propose to have a flow type to know what type of flow it is. Is it Ethernet flow, MPLS, or IP flow? Because it is useful and important at the edge nodes when adding or removing encapsulations. There is the flow specification part that, okay, how do we describe the flows, the source, destination address, labels, VLAN IDs, whatsoever. And there is the traffic specification, the traffic characteristics of the flow itself, the packet interval, packet size, and maximum number of packets. The flow endpoints belong to the flow description, and it's been there in previous drafts as well. The flow rank that can be used to rank flows in case of a race for scarce resources, for example. And the flow status is it established, supported, or there was some failure. As for requirements, flows typically have bandwidth requirements, packet delay requirements, packet delay variation requirements, and loss requirements. And we suggested to have a parameter called bidirectional to indicate whether actually, so all of the flows are basically unidirectional, but a flow may have a pair in the other direction. And in some cases, actually, you may want to have them routed congruent or something like that. And in this case, it is good to know if these two flows belong together. And this is one of the examples when this management flow ID becomes handy. So it's only for the management purposes to know that, for example, two flows should be co-routed. Another big surprise that the Detnet flow parameters in the green box are very similar to the app flow parameters for the reasons I mentioned. For example, Detnet flow may become an app flow. So Detnet flow has characteristics and requirements, and as part of the characteristics, the flow ID for management purposes, the payload type, and then here comes some new parameters specific to Detnet. So we have two data plane solutions, MPLS and IP. Okay, what is this flow format? The flow specification, it can be labels like the S label or a stack of F labels in case of an MPLS data plane, or a 6-tuple if we use IP data plane for .NET. The traffic specification is very similar to an Flow. It has the interval, the packet size, and the maximum number of packets. And as for the endpoints for the .NET Flow, these are the ingress or egress endpoints we propose to introduce. And flow rank is similar. Again, if rank can be very useful when doing resource allocation and not having enough resources, if you have to make a decision which flow gets the resources. Flow status, like was it successful, the flow establishment or not, for example. And as part of the requirements, a .NET Flow can have minimum bandwidth requirement, maximum latency variation, maximum loss, maximum consecutive loss tolerance, how many consecutive packets are tolerated to be lost, a maximum misordering, how many number of packets can be misordered and tolerated by the application actually. And again, a similar parameter, is it does this flow has a corresponding flow in the other direction, in a sense that do we support a bidirectional application? The blue box is the description of the service, and this is a little bit different compared to the flow, because the flow is coming with requirements, characteristics, and in the .NET network we establish services to support these flows, which has correlated but slightly different parameters. We suggest to have an ID for a .NET service as well, a service delivery type analogous to the previous one. It's either Ethernet, MPLS, or an IP .NET service. And another proposal to distinguish point-to-point and point-to-multipoint .NET service types. Note that multipoint to multipoint can be constructed from point-to-multipoint services, in which case this bidirectional becomes handy again to indicate they are correlated. The service rank is similar rank as I explained before, and here comes the difference of a service. Actually, it provides a delivery profile. So this is what the service provides you, delivers for you, gives you a bandwidth, latency variation, and so on. There is the service bidirectionality I already touched upon, and the service status. Similarly, like is it up and running, or is there any issue on either endpoint? Yes.
Very brief question. This
I'm
is
sorry, I didn't catch your name.
Please.
雪松 from Huawei. A very brief question. What is the relationship between the parameter in the green box, the .NET flow format, and the parameter in the in the green box? It is called the .NET flow format. In the blue box, it is called the .NET service delivery type. What is the relationship of these two parameters?
So the relationship is rather in the green box, there is the .NET payload type. Mm-hmm. That is related to the service delivery type. So what is it like when you look at the .NET service, is it like a layer 2 service that provided by .NET service that is for in the green box a layer 2 Ethernet .NET flow or layer 2 app flow?
I can understand the payload type is different, right?
Yeah.
But the flow format and the delivery type, I think it should be the same, right?
The flow format means, is it an MPLS .NET implementation or an IP?
So,
and you saw that in the data plane there are mixtures, like you can have MPLS over IP and so on. So in the same network, actually, you may have the very same packet network may provide both type of data planes in some form, .NET MPLS or .NET IP.
Okay.
And it's good to know which one it is. That's the idea behind.
Okay, so the result is that the conclusion is that it can be different.
Yes.
Okay.
Yes, thank you. Okay, 2 slides left, I think. So this is about mapping of these flows and services. There is a many-to-one mapping when it comes to app flows to .NET flow mapping. So multiple app flows can be supported by a .NET flow. Multiple app flows can be mapped to a single .NET flow. And coming back to the aggregation, one way of aggregation or one way of looking at .NET aggregation is when .NET flow to be aggregated into one becomes an app flow, and from the perspective of the aggregate .NET flow. And the mapping of .NET flows to .NET service is also a many-to-one mapping. Single .NET service, blue one, may support multiple .NET flows, and you see also the red items, the multiple app flows. So this is how we see the mapping. And actually, so this is, as I said, this was a contribution from the authors. We really would like to have working group review and comments. Are there missing parameters? Elaborate the text, usual working group work.
Other comments, questions? So what's left to do before last call?
So we really would like to get feedback, because this is author's view, this is author's initial take on taking into account what happened to the architecture, what happened to the data plane. So a very good review is really needed.
Do you think you've captured everything that's happened in the other documents, in the data plane documents?
We did our best, but this was a first shot from our side as well. So
Okay.
self-review is useful always.
Yeah. So getting the additional reading by the working group, now's the time, is definitely. I suspect you'll want to wait until we resolve everything on the first set of documents before last calling this one.
Yes.
That said, do you think it would be beneficial or a negative to last call it at the same time as the data plane documents?
I haven't gone that far. I'm not sure. I mean, I really don't know. I mean, it will be several documents.
Yeah, the trade-off here. The trade-off here is we might end up with a lot of reading.
Change.
A lot of reading by the working group. The benefit is people will read it as a set and get the full picture. So I can see it both ways.
Yes.
I personally, well, right now I don't have a strong opinion. There will be 2 different shepherds here. So that. Or there could be 2 different shepherds here, because I'm not an author on this. So we have some, we don't, well, I'm not sure that matters, actually. Never mind. That doesn't matter.
Let's think about it further.
Okay. Thank you.
Thank you.
Shusan?
Okay.
Oops.
It works. Oh, sorry. Good afternoon, everyone. This is Xue Song, and I will introduce our work about the .NET configuration YAML model. In this version, we add a new author, Yuan Chao, and he contributes a lot for this work. Thank you for his contribution. And basically, after IETF 104, we received some comments from the working group, and basically the requirement is that make the .NET configuration YAML model fit in the design of .NET architecture and the data plane solution. So after the IETF 104, the authors have a lot of discussions, and we do a lot of work to satisfy the requirement. And so this slide is the introduction of our work. And basically, the parameters defined in the YAML model are similar to the previous version, and the structure is changed. Here is the result of our new work. Basically, we define for Detnet configuration instance. The first is the application flow instance, the service sublayer instance, forwarding sublayer instance, and some network instance. We can see in the left picture, this is the Detnet data plan protocol stack defined in the architecture draft, and the right picture is the picture shows that how we use the Detnet configuration instance we defined in this draft to configure the Detnet data plan protocol stack. We can see that it can match with each other. And here is the overview of the whole picture of the configuration YAML model. Basically, as I have just introduced, there are four classes of instance, and for each instance we have a list. Inside each instance, the structure is similar. We have a name, the operation, the in segment, and the out segment. Here is the parameters for each instance. In an application flow, the operations include sequence number generation. And the in segment is the application flow identification. It can be layer 3 application flow or layer 2 application flow. And it can also be a Detnet flow. And the out segment is a pointer to a lower sublayer instance than a service sublayer instance. Here is a question to be discussed, whether the sequence number generation of this operation should be defined in the application flow instance, because when we do the flow aggregation, the sequence number generation may be also required. So maybe it can also another choice is to define this operation in the service sublayer instance. Here is the tree of the YAML model. And here is the service sublayer instance. The operation have two classes. The first one is the service operation, including service initiation, termination, and the relay. And also it includes the service protection operation, the replication, elimination, ordering, and the combination of these operations. The in segment is the Detnet flow identification, and the out segment is the Detnet service sublayer encapsulation, and also a pointer to the lower sublayer instance, the forwarding sublayer instance. And here is the sublayer instance tree. And also the forwarding sublayer instance, the operation is the resource allocation. The parameters for this part is the traffic specification, and the in segment is forwarding identification, and out segment is the forwarding sublayer encapsulation. And also a pointer to the subnetwork instance, which is not included in the this version of the draft yet. Here is the tree. Actually, we don't receive very or a lot of comments from the mailing list. Here is the one of them from Lu, application flow or Detnet service proxy. This discussion is about the name of the. We think it's perhaps it can be a new sublayer for the Detnet, but I think from the Lu's opinion or from the chair's opinion, it is just the application flow, and so we keep it the name in the architecture draft, and so we call it application flow instance finally. And we also receive comments from David Black. And yes, about the big mask, I think we have a discussion about that in the previous slides, so previous presentation, so I won't repeat the discussion. Oh, David is coming again.
David was just going to this is David Black. Welcome. I'd like to say that I've managed to do something productive as opposed to the long discussion I caused in the last draft. I've just sent to the list the two changes to the IP data plane draft that will take out the bit mask and take out ECM for flow identification. And so once those changes are made, everything else should be able to fall into place by following that updated draft.
Okay. After the data plan problem is fixed, I think the YAML model is followed. Yeah.
And David, thank you for that contribution. By the way, there is a GitHub repo, and we accept pull requests in this working group. So anyone in the working group is welcome to not only review, but submit their own proposed changes that are specific.
Actually, I want to add one more comment for that discussion. I think what is make it so difficult to figure this out. Perhaps it is because it is not clear what is the relationship between the traditional diff serve with the Detnet. So if we can figure out what is the relationship between the current diff serve service and the Detnet, perhaps it is easy to see how to use the DSCP value in Detnet. Yes, perhaps it's another discussion. And continue the presentation. What is the next for Detnet configuration YAML model? I think this time the structure is can satisfy the requirement from the working group. So maybe this time the structure can be stable, and afterwards more detailed designs can be added to this structure, including the aggregation case, including some unsolved issues mentioned in the slides, also the subnetwork. And please review the draft and give comments, or just enjoy our work. And also, weekly discussion may be necessary for Detnet configuration YAML model, just like what data plan draft does, because it will contribute to the draft to go along with other drafts. Yeah.
Whatever the authors feel is the right tempo, we can, as the working group, we can make sure that the working group WebEx is available to you and for everyone to participate.
Yes, that would be great. Yeah, okay. So that's all. That's our work about the Detnet configuration YAML model.
So in order, I'm basically asking the same question that I asked Janos about what do you need to get to last call. It sounds like it's to wait till the other documents are complete and then update as necessary to align. But you think the major structural pieces are there?
Yes, but I think the problem is the subnetwork is still not in the draft. So
yeah, I think I had I made this comment on the list, or perhaps at the last IETF privately. I can't remember which. I think we have to have a framework that allows augmentation for specific technologies in the future, and as long as we have that type of framework that allows the augmentation for both the subnetwork and also on the app flow side,
yes.
we can continue to run ahead, and we can always add for example, the TSNs as their own documents to as an augmentation to the base model.
Yes, I agree of this part. But actually, another one is for Detnet configuration YAML model. Another one is aggregation case. If the subnetwork can be done in the future, so I think aggregation case should be covered.
Yes, that aggregation is certainly part of the core MPLS and IP documents, and that should be covered.
Yes. So if this part can be settled, I think it can be last call with other draft.
I suspect that it should follow, because if there's any changes that happen on the data plane documents, then that'll necessitate a change here.
Yes.
So maybe just right after, immediately after.
Okay. So
I think if we are very fortunate, maybe we'll be able to have everything last called by November. But maybe of all the documents we've talked about, but I suspect that we'll maybe be halfway through by the Singapore IETF. But it's still really good project.
That would be great.
Progress, excuse me.
Okay.
Thank you.
Thank you.
I'm Norm Finn. I'm one of the authors of the bounded latency draft that we think is coming along, about ready for adoption. Just a reminder, Detnet is about an upper bound to latency, not low average latency. that implies that if you know how long it's allowed to spend in the network and you've got a finite amount of buffers, you should be able to put in enough buffers to achieve zero congestion loss. And it drives the other way just as well. If you can achieve zero congestion loss, then given you've got a finite amount of buffer, there's only so long that a packet can spend in the network. Feedback that slows down flows to avoid congestion is not an option for what we do here. And we can get mathematically sound assurances that we can get latency and latency and congestion loss. There we are. So major changes from Rev 3 to Rev 4. Section 3 was reorganized somewhat. The paradigm for how to reserve flows and so on was not in the right place, I don't think. We've made all of the various queuing techniques that we have standards for that we know will give zero congestion in one section 6 as parallel subsections under section 6. We have given the various queuing techniques more equal attention. There was way too much in there about cyclic queuing and forwarding, not enough about some others, so we've evened that out. And section 8, parameters for a bounded latency model, has been deleted. So now, clause 3, how you create a flow in Detnet. One is you configure the network. Now that's not silly. You may provide the network, or you may turn on certain facilities in the network for doing Detnet, for example, and configure maximum bandwidths allowed on certain links, all sorts of things you might configure. Then 2 through 5, you loop. You have a flow that you'd like to get. You have to characterize the flow. You have to establish the flow the path is going to take. And then you have to compute whether or not you can accept that flow and what sort of latency you can give that flow. Typically, the flow has a certain amount of latency and a certain amount of packet loss it can tolerate. We talk about 2 different computations. There are 2 different models for how you figure out whether this flow can be handled by the network. One computation model, depending on what queuing techniques you use, it's likely that every flow affects the latency of every critical flow affects the latency experienced by every other. I should say Detnet flow, not critical flow. Every Detnet flow affects the latency of every other Detnet flow, which means when you add a flow, you have to recompute everybody's latency and make sure that everybody's still within the bounds they asked for when they started. Some queuing techniques allow you to say, when a flow says, "Can I come in?" You can tell the very first flow, this is the worst case latency you will experience, and you know that no matter what other flows come in, as long as they can be admitted by the network, they won't affect the first flow's latency. I call that the dynamic computation because it favors dynamism. That's the kind of situation you want when you've got lots of flows coming and going, unless you've got an awful lot of compute power. The static latency computation I think of as more suited to less dynamic environments. And if the results are satisfactory, you reserve the resources that are required and you tell the sender, go. So that's described in clause 3. Clause 4 and 5 we have gone over before. It involves queuing model and it involves the network calculus to figure out what the latency might be under the assumption that you've got using certain queuing techniques. Clause 6 lists the techniques. Preemption I won't go into a lot. 802.3, IEEE 802 allows you to interrupt a frame, transmit some other frames, go back to transmitting the first frame, interrupt it again, transmit some more frames. there can only be one interrupted frame. It's not multi-level interrupted frames. But the four main queuing methods we talk about are time scheduling, where every output queue is gated by a scheduled gate that turns that queue on and off. You can turn multiple queues on and off, and in which case you use whatever queuing techniques, whatever techniques you have, typically priority for resolving which one of those gets to transmit. We have the asynchronous traffic shaping, which, well, let's talk about IntServe first. 6.5 is IntServe. A lot of us know how IntServe works. It's old, but it still works, where you have a per flow queue for the Detnet flows and per class shaping after you go through the per flow queuing, which we call regulator in the bounded latency document. Asynchronous traffic shaping is really very similar to IntServe, except that you have fewer queues. You still have a state machine per flow, timed state machine per flow, but you don't have to have as many queues as you do for IntServe. And cyclic queuing and forwarding is double or triple buffering for each class on each port, where the buffers are cycled in synchrony across the network. I think you've seen this slide. This is cyclic queuing and forwarding, the two buffer version. Basically, at one moment, packets belonging to Detnet throws throughout the network advance one hop. And then click, all the packets advance one more hop. And click, tick, they advance one more hop. Every time the clock ticks, all the packets in the network advance one hop. It's easy to imagine, especially in a service provider network, that the time to get over the wire from one hop to the next hop is a time that is comparable in length to the cycle time. If that's true, your ability to do it with two buffers is cut down, because you have to get the packets out of the buffer on one hop, over the wire, and into the buffer at the next hop within one cycle. If that's difficult, you have to slow the cycle way down. That's not good. So you can go to three buffers. I was asked to show this because that got cut off at the last time for lack of time. Basically, you have three buffers tick on the input side in synchrony with the last hop's output buffer tick, delayed by how long it takes to get to this hop. So I tick in synchrony so that all the packets in the red buffer in the previous hop all go into a single buffer at this hop. So the input clock ticks, the output clock ticks. Input clock ticks, output clock ticks. And you go through the rotate that. Now you can use the full cycle for filling a buffer. You can use the full cycle time for draining a buffer, but the input's timing is offset from the output timing. Another thing with CQF that's worth mentioning, you can run CQF at multiple periods, fast and slow, for different classes of service at the same time to accommodate, so that you don't have to, you're not saddled with the choice of choosing a long cycle, which means you can have lots of different flows, but you spend a long time sitting at each hop, and a short cycle, which enables you to get good latency, but you can't carry very many flows. This summary chart is not in the document. It could become part of the document, but I think it's useful for us to look at. It compares the four basic services on certain, and shows that there are really good trade-offs and really good reasons why you would want to use any of these techniques. The time scheduled is really great because it allows you, for instance, if you have a machine tool that operates as many machine tools do on a cycle of communicate for a while, think for a while, communicate for a while, think for a while. If the communicate for a while uses up most of your bandwidth, it's nice to be able to run several machine tools and just stagger their phase. Run them all at the same cycle, stagger the phase, so I get to use the same network for different machine tools at different times during the length of the cycle. That requires time scheduling. That's not suitable for int_serve or diff_serve. That requires strict time scheduling. It's very hard to compute a good time schedule for a network, but it can handle almost anything, and it gives you perfect results. It's not dynamic, and you have to have a schedule in every hop. With int_serve or time-aware shaping, they are very good at efficiently using the bandwidth, so you have very little over-provisioning. That tends to be a somewhat difficult computation. You have to recompute everything whenever you change anything. So, and it requires per flow state. It requires a lot of queues, and it requires state in every hop for every flow. On the other hand, it doesn't require that you time synchronize all of your nodes in your network, all of your relay nodes. Cyclic queuing and forwarding, the latency computation is trivial. It's a sum. The latency you give one doesn't affect the others. It typically takes somewhat more over-provisioning to make it work because of the fixed cycle times don't necessarily fit every single flow. The nice thing is it requires 0 per flow state. All you need is admission control. You don't need to touch any of the nodes along the path when you introduce a new flow. That's good, but you have to time synchronize everything. And I will mention my little footnote here. This table is very much a generalization. There's lots of factors that can mitigate some of these differences, and there are other queuing schemes that have been proposed to make somewhat other trade-offs, which is good. Final steps. We want to, some of the terminology in the network calculus section doesn't really match Detnet terminology. That really needs to get fixed. We need a very small amount of work to have the formal delay analysis for CQF, and for the buffer size calculations need to be filled out. We have to consistency check with the other working group drafts, and we should be all done.
So to answer this question, we ran a poll a couple of weeks ago.
Yes.
It finished formally on the 15th. I didn't actually send out the closing message until today.
Yeah.
But it's adopted. So we're ready for you to submit it with the new name, and we'll have a working group document.
And so we encourage people to read it and comment on it.
That'll be the -00 version.
Yes. So I can do that hopefully today. Any questions? Comments? I must be doing a good job.
All right. Thanks, Norm. By the way, we are definitely running ahead of schedule. So if you are in the second session, please expect to present at the end, be ready to present at the end of this session. So we'll move things that are in the second slot up to our second session to this session if we can. By the way, we do have one presenter, the OEM presenter, who can't do that. So we still will be meeting at least for that discussion in the second session. Okay, thank you.
I'm Liang from China Mobile. This is an update of the layer 3 or long-haul large-scale Detnet latency service requirements. So we actually, following the comments we received from last IETF meeting, we approached more service provider to collect more requirements for long-haul Detnet service requirements. And this is an update of that draft. So sorry, just a little bit reminder that this is, I probably need to change the name of the document, the name of the document, because it's so similar to Nordfin's document, but these two are really not a requirement for Nordfin. It's quite a different view of the bounded latency thing. This is really a requirement for layer 3 type of services we see, for example, for the virtualized PLC, for remote surgery, etc. Those services requires long-haul Detnet deterministic network services. So that's really not to talk about how we calculate or how we're modeling the latency. And there is no solution or implementation specific in this document. So this is really a reference or justification for our working group to have a look and to have a review whether this is an interesting topic that we can adopt it in future work. So just a quick summary of what we have been doing since last time. So the previous version was there are only 3 requirements listed, and for this update we actually put more requirements and we categorize them to two different classes. One is technical requirements and the other is operation and management requirements. So we have altogether 7 requirements collected, and the first one about how the requirements of dynamic creation and modification, delete of the service, and also the second one is about the time variance tolerance, and the third one is to support the intercontinental or multi-domain or long-haul propagation delay. So that's for the technical requirements, and there are 4 other operational or management requirements, which will come further in the upcoming slides. So we also categorize the requirements as must or should, because some of them are, well, at present it's quite difficult to actually to realize. So we put it as optional. So in detail, the first requirement is to support in layer 3 determinist network service to support the dynamic creation, modification, and delete or deletion of the services. Basically, as Nordfin mentioned in his presentation, we don't want in long-haul service, we don't want the recalculation of everything when you add a new Detnet service to operators network, because this will give you scalability problem. So this is a requirement that we must support dynamic creation or lifecycle management, but with a minimum complication of recalculation of everything, for example, gate control or the resource reservation things. And the second requirement is to tolerate a certain level of time variance. Maybe I need to change the name. It's not time variance, but there are 2 parts of it. The first part is actually the time synchronization tolerance, because when you basically talk about long-haul transmission, you need to tolerate the time synchronization. When you connect to TSN domain, well, we can transmit the synchronization signal between domains, but in real network, either you don't have these capabilities of transmitting the synchronization signal, or the performance of transmitting the synchronization signal across a long-haul situation does not actually meet your performance requirement. So this is for the time synchronization. The second one is for your clock synchronization. We need to tolerate a certain level of jittering of the clock. Of course, for just give some examples of the figures we're looking at, for crystal oscillator, for sync E, and for 5G backhaul, you will have different level of tolerance needed. The third requirement in technical requirement is to support intercontinental long link propagation delay without sacrificing our deterministic performance. So basically, if we look at the graph on the the right bottom corner, let me try to explain this. So when you look at the cyclic forwarding or cyclic scheduling mechanism, we normally in a strongly synchronized situation, we require the packet to be sent and received in the same cycle, or in the same cycle of the cycling scheduling mechanism. And that leads to a consequence where you need to basically increase your period if you are transmitting the packet with many hops for a long haul situation. So that make your jittering performance to be proportional to your length of transmission. And that is something we don't really like. And for example, in smart factory situation, this can be solved. In local area network, it is easy to understand that the propagation delay can be constrained to a certain small level, and the jitter can be controlled because you can have a very small, very small cycling period. But for long haul, that will give you trouble. So there might be a need for a mechanism in data plane that the jittering performance is not proportional to the length of transmission.
Jan Schwaker speaking. Can I have a question, comments to this and the previous slide?
Yeah.
You in the beginning said that you want to set forth requirements without specifying solution, and actually it seems like you have chosen a solution, like a cyclic queuing mechanism. So, for example, you just heard about the asynchronous traffic shaping that doesn't have this type of problems. And the other assumption you are making in the previous slide is that the TSN domains are time synchronized, and that is not a must.
Yeah.
So you heard one example is asynchronous traffic shaping when time synchronization is not used. In many cases it is used, but it's, as I understand, maybe I misunderstood these two slides, but it seems you've chosen a solution.
No, I'm not choosing a solution. This is really just giving examples of how this requirement might result in choosing of solutions, but I'm not making, assumptions of choosing these solutions.
But the good news is that it seems that there are solutions to meet these requirements,
right,
like the asynchronous traffic shaping, if you are picking something from the TSN toolbox, or the 3-cycle cyclic queuing. We just heard about Norm. And the other thing, you mentioned the smart factory. I would not expect a long haul link. It's a smart factory is one factory, so.
Yeah, but we received some requirement from really large smart factories. They have different sites over the country, and they have a centralized control center where they want their control unit to be plotted there. There's several hundreds of kilometers. I know that might be niche market, but
yeah, something for the TSN people to.
Norm, your name?
Norm Finn. Thank you. Something for. I knew I had one. For the TSN people to think about is. I know I missed it when I was working on. Working on the bounded latency draft, I kind of wanted to put it in, but I wasn't sure how, and that's the paternoster scheme, which I think might be somewhat more useful in meeting this particular document's requirements in particular. Seems like it would go a long ways to meeting these requirements. And that's, we need to think about how to do that, whether that should be done with a draft, whether we should do that in TSN, what should we do?
Yeah. Thank you. So that's all for the technical requirement, and for operation and management. The fourth one is we laid out it like should have self-monitoring capability. It's basically when operator trying to sell their deterministic service to verticals, the verticals are normally not expert on network, so they would really like to have a visualized type of tool that can obviously see or obviously be verified or convinced that the service provider provided actually meet the SLA requirements or performance. So we would think that the self-monitoring capability is important for Detnet, but realizing this is costly because you need to collect a lot of data from the network and do a lot of analysis and portal things. So we put it optional. In 5 and 6, we didn't really put too much tests in the draft, and it's really simple that you need to be robust against DOS attacks, because when we talk about Detnet services, most of them are in very critical use cases. For example, V2X or remote surgery things. So the security is very important. And number 6 it must tolerate failures. Same idea, because it's critical. And the last one must be scalable. When we talk about long haul, we expect that hundreds or even thousands of servers running in the shared infrastructure of service provider. In terms of number of devices and in terms of number of flows, it's going to aggregate it in metro level or in higher core level. To make the network work, it has to be scalable in terms of connected device and activated traffic flows. Yeah, so that's all for the update. It's really an informational draft or informational work in our working group. We'd like to hear from the audience, from the community, whether this requirement is a good or at least useful reference for Detnet group to actually consider for future work. And we've seen some discussion over the list, and we think that we have collected quite a lot of requirements from service provider. So we would like really to call a working group adoption for this document. Lo?
Okay, Lo Anderson. Let me start like this. I really like this. So I think it's pretty close to working group adoption. Saying that, I haven't read the document, but if it's as clear as the presentation is, I think we are very close to go for working group adoption. I have a couple of small questions. Can you back up one slide? So the must and should in red here, are those the traditional IETF uppercase must and should?
That's a very good comment. I have to say, as written it is, but when we write this, I'm not that confident that I'm here to say, okay, I obey with the strict text description of IETF definition of a must and should. That need to be looking into more carefully by the authors, I think.
If it's not, you have to go back and actually revisit and change them accordingly. I had questions about the numbers, but they're actually here in 71772, so that's fine. Can you back up one slide more? You use... the first comment here is linking nodes failures are in themselves topology changes. So it's kind of the same thing. What I'm saying, if a link fails, that is a topology change. So you need to tweak the language around that.
Definitely, yeah.
Go back one more slide. So I'm a little bit confused about the long link definition here. You say intercontinental. Yeah, that's fine. We can figure out what that is. Intercontinental long link, is that something even longer, or is it something else. So, but what I'm pointing at here is actually there are words like long, big, massive, whatever, that is not defined. And I think we should put some effort into actually defining what it really is.
Yeah, that's very good suggestion. Now we'll really take good care of the language here, because yes, basically a little bit of explanation of this. It's really not that complicated to have this so many words to describe long or intercontinental. It's really just a long haul situation. So we need to rephrase the words to better describe this. Thank you. So, any more comments and questions?
Okay. Sorry? We're taking a remote question.
Oh, yes. Right.
Ethan?
Yes. So this seems rather like the use case draft in the sense that it's looking at making sure that the capabilities agree with the real world requirements. And I guess one question I had was some of the things that you mentioned here seem to be already part of the common themes in the use case draft. So they seem to be already a part of what we're doing here. And also, I guess in the use cases draft, we've specifically avoided the must and should and words requirements because we're trying to guide the work and not define what has to be done. So I guess if we were to adopt this as a work group document, I guess I'm trying to figure out what the relationship between this would be and the use cases draft. Have you thought about that?
Yeah. Well, I understand your concern, but the use case is really in a service or application point of view of describing what the application needs, what application actually require the network to be like in terms of functionality and performance. But this requirement is actually technical requirement. The use case is service point of view, but requirements network point of view. Use case could be a guideline for the working group or the Detnet to consider what Detnet in terms of technical point of view required to have this type of functionality or this type of performance. So I don't see they are overlapping, but I might need to review. I have a long time not reading use case, but I might need to reread it and to see if there are any, misunderstanding how this draft is phrased to make you have this kind of concern.
So actually, the use case documents sets forth requirements, and it's a good set of requirements, but it could be one chapter, service provider network use case with its requirements in the use cases document. Well, it's a bit late for that because we have published the RFC, but that could have been one way to approach.
But I think when we talk about requirements, people have different understandings. Sometimes it's like use case requirements, like in 3GPP requirement can stand for use cases. But this requirements document really does not talk about use cases like video, audio, or things like that. It's really what the network we think need to be function or need to have that sort of performance. And given the fact that use case has been published,
yeah, but one of the requirements in the use case is, for example, for factory automation, the machine to machine, the number of consecutive packets can be lost. That's a very specific network requirement that has been rolled into later on in the document.
Normfin, have you, reading the document, have you made a clear distinction between synchronizing time in the various parts of the network and having the same frequency in the various parts of the network. I know that there are service provider networks that maintain frequency lock without necessarily time synchronization. And for example, CQF can be made to work with frequency synchronization without necessarily requiring absolute time synchronization. And some of the other techniques also work, can give really good results with frequency lock without synchronization lock. Do you make that distinction in the document?
Yes, we did. If I can go back, it's basically the time synchronization and the basically we distinguish the, as you said, time synchronization or time variance and the clock or frequency variance into two different requirements. I need to rephrase the title. The title is not correct. It's not time variance. It's really time and clock.
So asynchronous clocks, does that mean that you have also different frequency domains?
That's yes, that's what I understand. What I don't understand as
so from one domain to another, they may be operating not just different frequency, but you're saying within the domain it's fine to have this. You can operate with.
You have certain level.
It's not a problem to have frequency lock,
but that needs to be within a tolerance.
Well, everything's within a tolerance. Yeah. There's no such thing as perfect.
Yeah, definitely. It's reference to for example, for 5G backhaul. I don't remember the exact number, but it's smaller than the previous two examples. Then that's the tolerance we need to obey for clocks asynchronization.
Norm, it sounds like, I think this is probably a good conversation to have offline.
The key numbers I remember from 5G,
Name, please.
Stuart Bryant. The key numbers I remember from 5G are 1.2 microseconds, or you can't work at all. And there seem to be a whole variety of different numbers between 350 nanoseconds going down to 150 nanoseconds to get the optimum use. So I can imagine that those sorts of qualities of time are going to be almost commodity in the network because every transmitter is going to need it.
My name is Uma Chunduri. I think the number Stuart mentioned, we need to differentiate between the front haul, that is the G node B to the base station, and the back haul. There may be some differences. We need to look into that. Do you have any idea on that numbers? Actually, what is the clock sync requirements?
You mean the exact number for front haul?
Because you mentioned backhaul here.
Yeah, but I was doing backhaul for a long time before 4G and 3G, but I don't remember the exact number for 5G, but I can check that.
Just one more note on the time sync. I made actually on the list that so I'm not sure if it is Detnet requirements really on time sync or these time sync requirements are onto Detnet, because we said that we may in a deployment you choose your time sync solution you prefer to and adequate for you. So I'm not sure if we should make the time sync requirement to Detnet or so. It's a really good work, really good set of requirements. I'm not sure how to document and what further clarifications are needed. I'm struggling with the time sync, for example.
Right.
So I think we need to wrap up this conversation. And to do that, I'd like to understand from the room, how many people in the room think that this topic is one that the working group should continue discussing, and be working on to refine and to document. Remember, the product of the IETF are documents. So is this something we should be working on with an aim towards documenting? So if you think this is something we should be working on, can you put hands up? I'd call that a reasonable number. How many think we should not be working on this? No one. So that's pretty clear. How many folks have read the document? It's less than were before, but still a reasonable number. How many think that this is a reasonable starting point for our work in this area? Each time we've had less hands, this is an okay number. The other two numbers were good. This is just okay. So I think there's a little weakness there. So let's maybe you talked about some updates. Perhaps go through those updates. See if we can have some more discussion. Continue the discussion on the list. Yeah. And if we really want, we're going to have time in the second session. You can come back and we can talk about it more. So if we want, we will have more time to talk about it. I sort of think we're reaching diminishing returns for the rest of the group. We don't count individuals or specific numbers. Okay, I think Andy was putting his hand up for all three. One additional hand isn't something that. Okay, so we were just having, since others can't hear the mic, we just had someone who wanted to make sure that if they were remote, they wanted that comment was captured. We think the comment has been captured. If someone remote has something to say, just say at mic and we'll make sure to get it in there. All right, so thank you. And again, we're going to have time afterwards. So if we want to have discussion on this, we should take advantage of the fact that we're all here. So thank you.
Thanks a lot.
Now, we're going to jump now to the control plane framework. Shusang, are you still in the room? Yeah. Yes. Oh, no, I'm sorry, wrong document. It's still you.
Yes.
But I had the wrong title.
Perhaps the control plan is in the next session.
Right. So I'm sorry.
This is Xue Song, and I want to introduce our work about the Detnet SRv6 data plan encapsulation. Actually, the data plan works for the Detnet is kind of going to be closed, or a lot of work has already been done, but we still think it's necessary to discuss some new topic to this area. We want to use SRv6 as a very useful tool to carry Detnet service. I'm not sure whether all the people in this room are familiar with SRv6. Basically, SRv6 is the segment routing that is applied to the IPv6 data plan. The SRv6 header is the extension of the IPv6 header. And there is a segment list in the SRH, which can indicate the path of the service. Also, the optional TLVs are included in the SRH. And the network programming is allowed in SRv6 because the functions can be ended in the seed of the SRH, and this function can indicate the packet processing in a particular node of the Detnet domain. And here is the Detnet SRv6 data plan requirement. First, we should have a method of identifying the SRv6 payload type, not DSCP value, but some other method. Second, a suitable explicit routine to deliver the Detnet flow. This is naturally supported by SRv6 because we can define the segment list to do this. And a method of indicating the packet processing, such as packet replication, elimination, ordering function. And also to implement these functions, we will need the identification of the Detnet flow and also the Detnet sequence number. Actually, also we should have a method of carrying, queuing, and forwarding indication to do the congestion protection, but this is not covered in this version of the draft yet. Here is the SRv6 data plan solution overview. Actually, we list some options about how to do this. Basically, we should carry the flow identification and the sequence number in SRv6 header. The first option is we can carry this in SRHTLV. And the second option is we can extend the function and carry it in the arguments of the seed. The third option is that we can define a new Detnet seed for this information. And this seed is not for routing, it's just for Detnet. And here is an overview how to do this. This is an example of how to use SRv6 to do packet replication and elimination. It is not the only way to do this. It's just an example. First, the end station, it will send out IPv6 packet, and in the egress, the packet is encapsulated with an outer IPv6 header. This IPv6 header 1 is carried with SRH1. And this SRH1 will steer the packet from the ingress node to the relay node 1. And the function in the SRH1 will indicate the packet to do replication in relay node 1. And this packet is replicated into two packets, and the packet is also decapsulated and encapsulated with two new headers. One of them is IPv6 header 2, and one of them is IPv6 header 3. And the SRH included in these three IPv6 header is different because these packets will go through different paths to avoid equipment failure or other causes of loss. And in the relay node 2, the redundant packet will be eliminated, and the left packet will be forwarded with a new IPv6 header, IPv6 header 4, and the SRH4 will steer the packet from relay node 2 to the egress. And in the egress, the packet will be decapsulated, and the native IPv6 header will be remained, and the packet will go to the end station 2. So in this picture, we can see that with SRv6, we can implement packet replication and the elimination, ordering, and all these functions easily. So I think it's a good option for Detnet with SRv6 implementation. Actually, this document is aimed to become a working group document. More comments are welcome. Here, I said the document is asking for working group adoption. This is not because the document is perfect now. This is just the second version of this document. Just because that the document of data plan solutions in the Detnet working group are just under discussion. If we can adopt this draft, I think we can catch the discussion, and all the data plan solutions can be considered together. Yes, please, Janos.
Yes, I have a question. Actually, I'm a bit confused on what you are exactly after, and I'm trying to figure out what is the reason for confusion. So, segment routing we always discussed is one of the tools to establish the explicit routes for pre-auth for Detnet.
Yes.
And the working group has chosen to specify an IP data plane solution without actually any new IP data plane field for Detnet.
Yes.
And reading this, I see it's kind of a new IP data plane for Detnet with new fields in the SRv6 framework or something like that. So are you proposing a new IP Detnet data plane specific to SRv6?
I think kind of, because I think the previous IP data plane solution for Detnet is more about the native IP, not SRv6, right? And this is the extension for SRv6, so it's a totally new story. Yeah.
Microphone, please.
Mm-hmm.
No, I think it clearly is a new one.
Stuart Bryant.
It clearly is a new one. Sorry, I keep forgetting.
Mm-hmm.
Sorry, it clearly is a new data plane, but it serves as properties that we don't have in the existing ones, and we should look at it seriously. I think we should also take into account there's a huge amount of work going on in SR at the moment and network programming. If you were in Spring this morning, and goodness knows which one of those is the right one to pick.
Yes, and this document will also be presented in the I think tomorrow in the 6-man working group, and we just try to show this work to more people who are familiar with SRv6, and we can seek feedback from them. But we also think it's very necessary in Detnet working group to see the SRv6 can do this, can implement Detnet. I think it's necessary.
Yeah, I think I probably agree. It's certainly necessary to have pre-auth in the IP domain,
yes,
for sure.
Yeah.
And I guess people want an SRv6 solution as well.
Yes, thank you.
So there clearly is, as Stuart mentioned, for those who attended the spring working group, there's clearly a lot of flux in SRv6 at the moment. That is a good thing to be aware of and something separately to track. We first have the first question is this a topic, Detnet SRv6? Is that a topic that this working group wants to be working on with an understanding is that goes beyond the current set of data plane solutions we've been looking at? So do we want to expand our solution set to include SRv6? If you are interested in that, can you put up a hand? There's a few people. If you think we should not be working on Detnet SRv6, can you put up a hand? Lola doesn't like how I phrase the questions for some reason. So if you think we should not be working on that. Okay, so the first one had a few, the second one had none. So I think that's reasonable information. I've now generated a queue. Pascal.
Pascal Tuber. So I'm curious because there are two things, right? There is to lay out the path. And then there is the dynamics of this, like how many packets go through this path, and now you tune your queues, etc. And I see how SRv6 can be used to quote-unquote serialize a complex path, which is not necessarily a series of hops. So we can serialize stuff. I see less how you can signal everything we need to signal in the packet, right? Like the rate or anything like that. That has to be a state which is maintained in the hops. So whatever you do, it seems to me that there is a balance between what goes in the packet and what still must be a state that still needs to be resident in the hops. Yeah. At the very extreme, we've already have work at beer, where the bits just indicate the segments, like replication, but nothing about the real time or anything above, just one bit to say I'm using it. Meaning that the path is strictly already laid out, just like in Detnet. Everything is in the hops, all the state. And what we do is just decide per packet whether we use this reservation for this packet or we don't, just to save resources. Right. When I see this, I have a feeling that you could signal the exact same thing, or you could signal more, but I don't see that you can signal it all. you still need the state. That's this balance I'm curious about and how you feel about it.
Actually, I understand your concerns, and I have read your draft about the beer kind of solution. I think it's really an interesting option for do a packet replication and elimination, because the packet replication and elimination this function kind of similar to the multicast case. So if we use beer, it's natural. Yes, it's a natural idea. But it's totally different story between the beer and SRv6. In beer, we just use the bit to show the path, and we don't need more status in a node. Yes, it's a good choice. But yeah, I think it doesn't means that the SRv6 solution is not valuable or useful. Yes, I think it's another solution, another way, and actually, if this works, I think it will be good too.
This is Stuart Bryant again. So I think there's two high-order bits. First off, we do need a full-blown IP solution that will be deployable in regular IP networks. Now, whether those networks will be running SRv6, I don't know, because SRv6 is really more of a service provider sort of domain. So even if we do this, then there's still potentially a demand for a regular IP full-blown solution. Secondly, this has to align with what is going to get deployed for network slicing in practical 5G networks. And as far as I know, the industry is still not quite clear what it is going to do. I know there is a big push for SRv6 for this. Equally well, what I hear from 3GPP is they're not necessarily sold on that as a design.
Yes, I think the intention of this draft, they won't just I think it's just another option to do Detnet with SRv6. But if we want native IP, I think that the current worker can cover the requirement, right? And if we want to do this with SRv6, and we have a new draft, just that is the intention.
Now, the current work does not support full Detnet in a regular IP
current
network.
work?
Yes.
The data plane drafts that we've been writing, the ones,
Yes.
Stuart again,
Yes.
the ones that we've been writing, they do not support the pre-off function.
Yes.
So we do not have a full service IP solution. And I think we should remember that. Now, if the people who want that,
So we have an equivalent one to this. We have IP over MPLS, and so IP over SRv6 would be an equivalent.
yeah,
one.
you could do it like that. You could certainly
Right.
do it like that.
We should probably move. We're actually running out of time, so we should go to the last two folks in line.
So, Lou Anderson, first, what Stuart said, I think I agree 100% with that. You said that I didn't like how you phrased the questions. And the reason I didn't like the question was that I think it's too early. We need to wait and see where SRv6 goes, and if SRv6 is going to be part of a Detnet type of network, then we need to do something. If it's fully a part, then we can leave it. But we can't make that decision today.
But Laura, I think I have to mention that SRH is stable now. I think it has already been adopted as an RFC standard track. So I think perhaps the SRv6, how to implement SRv6 in the future is still under discussion. But the encapsulation of SRv6, for example, the SRH, this kind of header is stable enough, I think. Mm-hmm.
So Mark from Huawei. So there's possible mention that the beer can be a candidate solution for.
Wait. So this is SRTE. This is not a beer talk. If we have a beer, stop. If we have a contribution, Pascal. If we have a contribution that talks about Detnet and beer, we should talk about it there. We should not talk about beer right now because we are actually over time. So this topic is SRv6. If you have a comment, Mock, if you have a comment on SRv6, please make it. If it's about beer, please don't.
Pascal, can I say something? I should not have mentioned beer. I apologize for that. I was trying to say there is something you can signal in the packet and something which must be a state in the node. I was mentioning beer as an extreme case where everything is in the node but just enabling. And I was saying, hey, you have to tell us what goes in the packet, what still needs to be a state. That was just what I wanted to say.
So we're missing our cookies. What we're going to do is put both of these two topics at the end of our agenda, this one and the previous one, and bring up the speakers and see where we go from there. And if we have more conversation, we'll take advantage of the time.
Yes, okay.
All right, so we will be back here in 15 minutes. They give us separate. It doesn't matter to me.
It's here in this room.